Good evening, friends. This is Pranayappan from Mind Campus. Let us see the Unit 3 sequential circuits. This unit, we can expect question from what is the sequential circuit, what are the differences between a sequential circuit and a combination circuit. I clearly explain you what this combination circuit is. Combination circuit means output depends upon the combination of the present input alone. That means no past inputs are considered. That is combination circuit. And sequential circuit means it must have memory to hold the past values. Okay, so that is a sequential circuit. In this unit we are going to see the different types of sequential circuits designing. These are the things we are going to see. We are also going to see the different types of flip-flops. The important topics in this unit are flip-flops. You can expect flip-flop question, design of a counters question, and deriving the output sequential circuits and designing of asynchronous circuits as sequence circuits. These are the important topics in this unit. You may expect questions from these topics. Okay, let us proceed with the first question. It has been asked, determine the sequence for a sequential circuit. A of t plus 1 equal to, this is the expression they have given. For b of t plus 1, they have given it as a. For c of t plus 1, and they have given it as b, and d of t plus 1 equal to c. When 1 x equal to 1 and initial state as 0001, when x equal to 0, for initial state as 000 and 0. So we have to derive two cases, when the initial state as 001 and when the initial state as 000. Okay, let us assume that initial state is 0001. So it has been given ABCD is the variables. So ABCD equal to 0001. That means A equal to 0, B equal to 0, C equal to 0, and D equal to 1. So if this is the condition, A bar will be 1, B bar will be 1, C bar will be 1, D will be 0, D bar will be 0. Now we can substitute these values in the expression and find what is the next state of a of t plus means t plus 1 means the next state of a. So a of t plus 1, we substitute the value and we evaluate the value as 1. Similarly, b of t plus 1, this is, so we can frame the sequence a b c d. So a is 1, b is 0, c is 0, d is 0. So the next state will be 1 triple 0. So if the first state is 0001, the next state is 100. In the same way we have to proceed. So we have to proceed and find the next states. So but after a particular sequence, the states will start repeating. Again it has reached 0001, and again it starts the same repetition it has started. So we can finish this up to this. So this question is asked for as 13 mark question in a University April May 2023 question exam. Similarly, now we need another case we have to work it out. When x equal to, when the initial state as 000, when that means x is 0 and initial state as 0000. So a of t plus 1 is 0, b of t plus 1 is 0, c of t plus 1 is 0, d of t plus 1 is also 0. If I substitute the value in the equation, the same. So it indicates there is no state change. Hence, the same state will be retained for x equal to 0 when the initial state is 000. So we have given the conclusion what will be the output when the initial state is 0, when the initial state is 0000 and the input value is changed to. Now this is the circuit. Design the below sequential circuit using JK flip-flop. Okay, so they have given the diagram. So from the diagram you have to draw the flow table. So here the two variables are A, B, and this is how you have to change, how you have to look it out. If it is given slash, that will be the output case. So when AB is 00, when X is 0, it will be retaining the same state. It will be retaining in the same state. When X is 1, it is moving to 01 state. So we can give the state names as different. Okay, since we are having two variables, we can have four possible values: 0001, 1011. Okay, and there may be a possibility of two chances of the input values when x equal to 0 and x equal to 1. So say we have to form the from the diagram we have to form this table. So when x equal to 00, there are two combinations. two possibilities when the x value to be 0 and x value to be 1. When similarly, when x equal to 0 1, when x equal to 0 1, there are two possibilities, x equal to 0 and y equal to x equal to 1. Similarly, for 1 0, there are two possibilities, x equal to 0 and x equal to 1. And for 1 1 also, for x equal to 0, it is retaining the same state, and x equal to 1, it reaches to 0 0 state. So with this, you fill the table. So when x is AB is 0 0 and x is 0, it is just reaching the same state. So it is mentioned the same 0 0 again. When x is 0 0 and y output is, sorry, AB is 0 0, output is 1, x is 1, it means it moves to 0 1 state. So from the diagram, I am filling all these things. What is the A plus B plus? A plus or A of t plus 1 will indicate the next state. So this is from the diagram, up to this from the diagram what it has been given. Next we have to frame the JA and KA. Now we have to design this using the JK flip-flop, JAKA. If JK flip-flop condition for that is, if the same state is maintained, then JA value will be, if Q plus, that means present state and the current state both are same, means JK equal to 0. If q is 1 and q bar is 0, means q is 1 means q is set, output is set. So set value here, j is 1, k is 0. If q bar is 1, q bar is 1 and q is 0, that means it is resetted. So in that case, k equal to 1, j equal to 0. So this is the combination, and both combinations 1 and 1, it is undetermined in case of its flip-flop, JK flip-flop. So in this way, we can fill this JA and KA values. Okay, we have to look in this way. Present state is 0, next state is 0, no change. So JK will be 0. JK will be 0 because present state and next state. Here the change state is changed from 0 to 1. That is, output is set. So set value means J is 1, K is 0. We will see the 1 0 combination. Here you can see. Here A is 0 1, A plus is 0. So it is resetted. So K equal to 1. So in this way we have to fill by looking A and A plus for JAKA, B and B plus for JBKB. So now we have finalized. We have to derive the equations for JAKA, JBKB in terms of ABX. So we can follow that K map and get the simplified expression, and we can draw the diagram with with the equations we have derived it. Next question: design an asynchronous sequential circuit that toggles with every clock. So it has to toggle for every clock. Assume input as 0. So it was asked in the year December 2022. So the toggle flip-flop toggles with the application of every clock pulse. So we can simply design a toggle flip-flop with a we can design a toggle flip-flop. That's it. That is enough. So this is the truth table of a toggle flip-flop. Toggle, okay, toggle and q of t plus 1, q of t plus 1. We are going to design the toggle flip-flop with the help of a JK flip-flop. So using the same relations. So if toggle is 1 means q will be, and the output will be changed. If output is 0, output next state will be, current state is 0, next state will be 1. Only when toggle is 1. When toggle is 0, the same state is maintained. So this is the case. So we can design a JK flip-flop. Sorry, D flip-flop using JK flip-flop. Just we are fastly recollecting the. I have given you the problems in your classes. Just I am rushing up to have a fast glance. Okay, mod 6 counter. So it will count up to 6 values from 0 to 6. Okay. So 0 0 0 starting from we are framing, and next state. So for this is the current state, means next state will be this. So this next state will be going here. For this combination, next state will be this. So it will be coming here. For this will be the next state. So it will be coming here. Likewise, it has to be go. For this, where is your earlier state? That will be the last state. So you have framed the table. Now we have to derive the now we are designing the same with D flip flop. So simply we can copy it with the because whatever you need as in the output, you must give that as the input. So simply we can copy this for the D inputs alone. அதாவது நம்ம இதை தான் அவுட்புட்டாக வரணும்னு நினைக்கிறோம். ஸோ அதை அப்படியே காப்பி பண்ணி எழுதிடலாம். டி ஃபிளிப் ஃப்ளாப்பாக இருந்தால், இதே ஜேகே ஃபிளிப் ஃப்ளாப்பாக இருந்தால் வி நீட் டு கன்சிடர் கரண்ட் ப்ரெசன்ட் ஸ்டேட் அண்ட் கரண்ட் ஸ்டேட். ப்ரெசன்ட் ஸ்டேட்டும் ஜீரோ, நெக்ஸ்ட் ஸ்டேட்டும் ஜீரோனா சேம் ஸ்டேட் மெயின்டைன் ஆகிருக்கு. இன் தட் கேஸ் ஜே அண்ட் கே போத் ஜீரோ. ப்ரெசன்ட் ஸ்டேட் ஜீரோ, நெக்ஸ்ட் ஸ்டேட் ஒன் அப்படின்னா q வந்து செட் ஆகிருக்கு. இன் தட் கேஸ் ஜே இஸ் ஒன், கே இஸ் ஜீரோ. ப்ரெசன்ட் ஸ்டேட் ஒன், நெக்ஸ்ட் ஸ்டேட் இஸ் ஜீரோ. q2 is 1 here, q2 plus is 0. அப்போ ரீசெட் ஆகிருக்கு. அப்போ k equal to 1, j equal to 1, j equal to 0. So this is the logic we have to apply it. Okay. So keep in mind we have only jk flip is flip. Just only the name change. இந்த ஒரே ஒரு நேம் மட்டும் தான் சேஞ்ச். ஜேக்கு பதிலாக எஸ், கேக்கு பதிலாக ஆர். Okay. You just keep in mind. So now we have to simplify the equation using Carnap map and must draw the circuit. Okay. Design a counter to count in this sequence. They may ask the sequence in different manner, different way. So in this sequence, if you want to count, we must write the initial sequence. It starts from 001, next is 100, next is 011, next is 101, next is 111, next is 110, next is 010. So in this sequence, we have to proceed. So for 001, next state is 100. So it will be the next state. For 100, next state is 011. So this will be the next state. This is the next state, so it will move here. Like that, so you will fill it. Now we are going to fill up using flip-flop transition. JK flip-flop. So this is the JK flip-flop. If same state is maintained, means J is 0, K can be any value. Either it may be 0 or 1. If present state is 0, next state is, that is state is, next state is set means j is 1, that's it. K any value it can be. Similarly, if present state is 1, next state is 0, k is 1, j can be any value, need not be 0 0 alone. If both are 1, don't care conditions, that's it. So using the same two table, you check into q2 q2 plus q and fill j2 k2. Similarly, q1 q1 plus you fill j1 k1. Q0 q0 plus you fill j0 k0. Okay, this is how it has to be filled. I hope it is clear now. So thus it has to be filled. This table has to be filled. Next, we have to derive the K map and we have to draw the circuit. That's it. So I have framed the equations and drawn the circuit. Okay. Design a BCD ripple counter. So this is the ripple counter. So it will count in the ripple sequence. So it will count from 0002 to 1001. So in it cards, it starts from charge. It starts from